The new research paper provides an explanation for the two strange events that occurred in Antarctica. High-energy neutrinos appearing to come up out of the Earth on their own accord and head skyward. The anomalies were spotted in 2016 and 2018 thanks to the Antarctic Impulsive Transient Antenna, an array of radio antennas attached to a balloon floating roughly 23 miles above the South Pole. Scientists were looking for cosmic rays, so naturally, they were perplexed, with more than 40 papers published outlining possible explanations, some proposing they were the long sought after dark matter or sterile neutrinos. But the suggestion of a parallel universe took the prize. Though sensational, this theory is not new, as this concept of an anti-universe is a well-studied idea that the Big Bang should have created two universes, our own, and an anti-universe that from our point of view, extending backwards in time before the Big Bang. But Ian Shoemaker, from the Virginia Tech College of Science, has a different, simpler explanation, suggesting that the anomalies are not from neutrinos, but are merely unflipped reflections of the ultra-high energy cosmic rays that arrive from space, miss the top layer ice, then strike the deep, compacted snow known as fin. In a press release, he said last week, "We think subsurface fin is the culprit. Fin is something between snow and glacial ice. It's compacted snow that's not quite dense enough to be ice. So, you can have density inversions, with ranges where you go from high density back to low density, and those crucial sorts of interfaces where this reflection can happen and could explain these events." Dr. Shoemaker says while the discovery is still interesting, it may not be Nobel Prize winning. He added, "Whatever Anita has found, it is very interesting, but it may not be a Nobel Prize winning particle physics discovery. Anita still could have discovered something interesting about glaciology instead of particle physics. It could be Anita discovered some unusual small glacial lakes." Glacial lakes were another consideration by Dr. Shoemaker and his team for the reflections. These lakes, deep underground, though, are too far spread apart according to current research, and hence are not the most likely explanation. But if there are far more lakes than previously known, this discovery would be a big win for scientists who study the landscape and interior of Antarctica. He continued, "I didn't know anything about them, but they really do exist. There are lakes under the ice in Antarctica, and those would have the right reflective properties, but they're not widespread enough. Our idea is that part of the radio pulse from a cosmic ray can get deep into the ice before reflecting, so you can have the reflection without the phase flip, without flipping the wave. In that case, it really looks like a neutrino." Dr. Shoemaker finalized by highlighting the issue with this theory. He added, "When cosmic rays, or neutrinos, go through the ice at very high energies, they scatter on materials inside the ice, on protons and electrons, and they can make a burst of radio, a big nice radio signal that scientists can see. The problem is that these signals have the radio pulse characteristic of a neutrino, but appear to be traversing vastly more than is possible given known physics. Ordinary neutrinos just don't show this. But cosmic rays at these energies are common occurrences and have been seen by many experiments.